Hi, and welcome back. In the previous lecture, we understand the meaning of immutable object, and we ended the lecture with the question, what are the pros and cons of immutable objects? Let's answer this question now. The good thing about immutable objects is that they can be stored and reused. It is very efficient from memory and performance point of view if you want to use the same object over and over again. The second thing is that they are thread safe. Thread safe means that many threads can use them safely because once immutable object is created, we are sure it cannot be changed. Now regarding the downside. The problem is that for every change in the object state, even a very small one, the JVM will create a new object, which is not so efficient thing to do from memory allocation point of view, and also from performance point of view. Related to string, all methods which are work on it, such as substring, concat, replace, to lowercase, to uppercase, all of them create a totally new string object and return it. I gave a detailed example of substring implementation in the previous lesson. You are welcome to go back and look at it if you like to. So the most common problem is that every operation on string creates a new object, consumes more memory, and it has bad impact on performance. If you answer this question correctly, the interviewer can ask you the following next question. How can you overcome this memory and performance impact of string immutability? The answer is that Java provides us with StringBuilder and StringBuffer objects. Using this object, we can do operation on string without creating a new instance of it. Such operation can be append, insert, delete, replace, reverse, and more. All these methods return this, meaning the same object, and doesn't create a new object. Both StringBuilder and StringBuffer are used to manipulate string, but they are not immutable, and thus they can be modified. At any point in time, it contains some particular sequence of characters, but the length and the content of this sequence can be changed by using the object methods. For example, append method will add the input to the string buffer. Now let's open the append method of StringBuffer and see it. We can see here that the method is doing the append to the input string, but at the end it returned this object. StringBuffer method always returns StringBuffer itself and does not create a new object, as string methods are doing. This leads us to the next question, which is one of the most popular interview questions. What is the difference between StringBuffer and StringBuilder? Well, the answer is that StringBuffer are safe to use by multiple threads. The methods are synchronized where necessary, so that all operations on any particular instance behave as if they occur in some serial order. That is consistent with the order of the method call made. StringBuilder class provides the same API as StringBuffer, but with no guarantee of synchronization. Let's take a look again on the StringBuffer append method. We can see that the method is synchronized. If we open the same method in the StringBuilder object, we can see that the method is not synchronized. So the answer is that the difference between the two objects is related to their thread safety. This leads us to another question. Don't worry, this is the last question in this section. Which of the both should I use, StringBuffer or StringBuilder? Well, StringBuilder class was designed to replace StringBuffer in places where the StringBuffer was being used by a single thread. Usually, this is the case. Where possible, it is recommended to use this class in preference to StringBuffer, as it will be faster under most implementation. Let's open the sample program, StringBuilder sample. which demonstrate this difference between the string, StringBuffer, and StringBuilder objects. There are 3 methods here, and all of them are doing the same thing 50,000 times. They are adding the second string to the first string and returning the answer at the end. The append string method is doing that with the plus operator of string. The append string buffer method is using StringBuffer object and append method. And the last one, append StringBuilder method, is using StringBuilder object append method. I also add some code that measure time for each loop and print it out at the end of each method. What do you think the results are going to be? Okay, let's run the program and see the results. So the results are string took the longest time. From the other side, StringBuilder was the fastest. Can you explain why? Yes, of course. As we said, in string, JVM create a new object each time. It consumes a lot of memory and a lot of time. From the other side, StringBuffer, StringBuilder are much faster. Still, we can see that StringBuilder is the winner because its methods are not synchronized and it is the fastest. Okay, no more question. See you in the next lecture.